Hi dear students. So today we'll start a new topic of class 10 ICSC, that is calorimetry. Okay. So what is calorimetry? It's a totally new thing to you. Calorimetry is a topic where we study about heat energy. Calorimetry is a topic where we study about heat energy. But the name has come. Why calorie? Why we have not taken some another name? The reason is that earlier times the idea of heat as a energy, it is not been a popular thing. They have thought that whenever a heat is given to a body, some extra material, and to tell the truth, an extra liquid is moving towards the body. And as this liquid is going to a body, that's why the body become more hot. Example, assume if I am talking about it's a iron, this is a piece of iron, and here is the same piece of iron. Its temperature is 30 degrees centigrade. Its temperature is 90 degrees centigrade. The earlier people or the earlier scientists, they have thought that in the 90 degrees centigrade piece there is some extra liquid, and the name of the liquid they have given caloric. Their idea is very clear that whenever we give heat to a body, so this liquid calorie is just move inside the body, and that's why the body is hot. But later we come to know that it is not a liquid, it is simply a energy, a form of energy. And from then the idea of calorie fully goes out. But till the name calorie, it is taken, and it is known as the heat, because initially that one is representing the heat, and that's why the study of heat is taken as calorimetry. Metry means the study. Okay, calorie means heat, metry means study. So the study of heat or heat related anything is known as calorimetry. So it is the basic idea of calorimetry. Okay, now we have to come to the next part. What happens when a heat energy is given to a body? We all know that if I am talking about any bodies, it is made by molecules, right? If I am talking about the bodies, it is made by molecules. We all know, we have learned it in class 6, that by the help of molecules all the things are made. Okay, and it is having the same property whatever the whole physical quantity have. Okay, if I am talking about the molecules of solid, we have learned the molecular model of solid. There the molecules are very closely packed for the case of solid, right? And if I'm talking about the liquid, they are comparatively loosely packed. Okay, and for gas there is no packing, they can move whatever they want. Okay, so that is the idea of the molecules. And now we have to come step by step everywhere. Whenever we are talking about the molecules of solid, the molecules are cannot able to move, they are closely packed. Then what they have done, due to the atmospheric temperature, they just vibrate their own place. It just starts vibrating. So if I'm talking about the motion, that type of motion is very less in the case of solid. There is a very little vibration due to the temperature. And we know the intermolecular attraction is more. Here one thing we have to remember, more intermolecular force, that means the molecules we have seen here, they are having more potential energy. We have already learned what is potential energy in work power energy chapter, and there we have learned that potential energy is an energy which is possessed on a body due to its state of rest. So this attraction, this intermolecular attraction, giving the potential energy to the body. And as you see, the vibration is very less, so we can say for solid, kinetic energy is minimum, because they cannot able to move. So kinetic energy is minimum. Coming to the next part, if I am talking about liquid, their intermolecular forces are there, but the particles can able to move, but they have to move inside the boundary of the water. They cannot able to cross it. Okay, so here both potential energy and kinetic energy is there. Okay, I'm not telling this is equal, but potential energy is also sustained due to the intermolecular force, and kinetic energy is also there as the particles are moving. We know due to the motion what energy is possessed, that is kinetic energy. And for the case of gas, it is maximum kinetic energy and potential energy is minimum, very minimum, we can say that. Why I am telling this thing to you? See, these all are the forms of energy. When we have given additional heat energy to the body, then for the case of solid, the vibration will more. So we can say the kinetic energy is more comparatively to the potential energy. Here also the kinetic energy more, and here the only kinetic energy that is also increased. When we are talking about the total energy that we have learned earlier also, that is the total potential energy and total kinetic energy of the molecules, and that is known as the internal energy. Now, as you have given more heat energy, the internal energy of a body is increased. Internal energy is increased due to heat energy. More you given heat energy, more the internal energy, because it is clear, as you have given more heat energy, then completely, if I am talking about here, completely the kinetic energy of the molecules, that will be increased. And as the kinetic energy is increased, so the total energy, total internal energy will be increased. As more the total internal energy, then we can say you that the more heat energy is absorbed by the body. So this is the idea of heat energy. That means heat energy is what? It is a form of energy where we have measured the internal energy of a body. Heat energy increases the internal energy of the body. If you have taken heat energy to a body, assume you are having a cold body and a hot body. This is cold, this is hot. If you keep it together, so we know there is a heat exchange. The heat energy is coming from hot body to cold body. So as the heat energy is coming from hot body to cold body, then the molecules in cold body will get more internal energy, and as the heat of the hot body is reduced, so the internal energy is reduced. So that means heat energy is basically the measurement of the internal energy of the body. Okay, more you heat energy given, more the internal energy of the body. Okay, I think this idea of heat energy, it is clear. Okay, now we'll go for the next, that is unit of heat energy. Okay, so I think it is clear. It is the introduction part of calorimetry. So calorimetry is the study of heat. And what is heat energy? The heat energy is a form of energy which, if it goes inside a body, then their internal energy is increased. Internal energy of the molecules is increased. Now we are talking about units. If I am talking about the SI unit, you see, if I am talking about SI unit, then SI unit is equal to the unit of energy simply, because it is a form of energy, and SI unit of energy we have already learned, that is joule. So that is the SI unit of heat. But apart from this, one unit is being discovered very early stage, and that time it is discovered in a form of CGS. Okay, that is the French unit system. What is? It is told as calorie. The unit of heat in CGS is known as calorie. Achha, what heat energy is known as 1 calorie of heat? That one we have to see. It is told that 1 calorie heat is such amount of heat which increases 1 gram of water's temperature increased by 1 degree centigrade. So 1 calorie heat energy is such amount of heat energy which increases 1 degree centigrade temperature of 1 gram of water. That amount of heat energy is known as 1 calorie of heat energy. Okay. Now the question has come. When we are talking about water, the water is there from 0 degree centigrade to 100 degree centigrade. In this much range, water is in liquid state. So from where we have increased the 1 degree centigrade, whether it is 5 to 6 degree, or it is 40 to 41, or it is 91 to 92, which one? Which 1 degree centigrade is increased? Because whenever we have studied the whole increase of 100 degree centigrade, it is, we have seen that this 1 degree centigrade increase, all the time the heat energy absorbed is not same. All time it is not 1 calorie. Okay, so that means whatever heat energy is needed from increasing temperature from 5 degree centigrade to 6 degree, it is not same with 91 to 92, or it is 40 to 41. It is changed. Then how we can able to find out what is 1 calorie? Then we have taken a concept of average calorie. Take a concept of average calorie. What is average calorie? It tells us that 1 calorie heat is increasing the temperature of 1 gram of water from 14.5 degrees centigrade to 15.5 degrees centigrade. That is taken as the standard value of 1 calorie. That is, which increases the temperature from 14.5 degrees centigrade to 15.5. You see 1 degree centigrade here. That much amount of heat energy is taken as average calorie. Okay, is it clear? Okay, so calorie is a form, or we can say calorie is a unit of heat which we can able to measure by this way. Now we'll go for the next part, that is the relation between the calorie and joule. We have learned it earlier also, that is 1 calorie is equals to 4.184 or 4.2 in round joule. 1 calorie equals to 4.2 joule of heat energy. Okay, is this clear? Okay. Apart from calorie, one unit of heat energy we have used in our general use. What is that unit? That is known as kilocalorie. kilocalorie. Why? Because when we are talking about calorie, it is dealing with 1 gram of water. 1 gram of water is a very small amount. Kilocalorie is a larger unit. So here the definition will be changed. Instead of 1 gram, it is changed to 1 kg of water's temperature is increased by 1 degree centigrade. That is known as 1 kilocalorie. Whenever I have written that term KCAL, you are very much familiar with the term in case of biology. How much kilocalorie of energy we consume when we have taken a food. Okay, so whenever you have bought any sort of packaging food, it may be chips, it may be biscuits, anything. There you have, if you see at back, it is written how much kilocalorie energy you have consumed by that food. So it is a unit of heat energy. Okay, I think it is clear enough. That is all about the heat energy. One part is left, that is measurement of it. That we have to learn little later, how we can able to measure the heat energy. Next we will go to the temperature. Okay, because to understand the heat, one very important thing we have to learn, that is temperature. What is it? What do you mean by temperature? In general, when we are talking about temperature and heat, both is taken as that is the same thing. But temperature and heat, they are not same. Why it is not same? Let's see. Temperature is basically shown the effect of heat energy on a body. Temperature shown the effect of heat energy on a body. And basically we can say by the physical quantity we measure the degree of hotness and coldness of a body. We are very much familiar with this term, the degree of hotness and coldness of a body. So what is temperature? It is completely different with the heat energy. That is a parameter by which we can able to find the state, the thermal state of a body. That means the degree of hotness and coldness of a body. That is known as temperature. Which instrument is used to measure the temperature? That I know, everybody knows that. I will not tell it here. You will write it down in your copy. We are coming to the units. That also you know, the units of temperature. If I am talking about the SI unit, that is Kelvin. Okay, capital K. Okay, and without degree sign. And apart from this, one unit is taken, that is the CGS unit. It is also very much common, that is degree centigrade. And FPS unit, which is a British unit system, that is degree Fahrenheit. Till now you see, we have measured our body temperature in Fahrenheit, because you know that 200 years Britishers are here. So as they have come, we have taken many things from them. Okay, if I am talking about the education purpose and modern science, many things we have taken. One of the units we have used nowadays also, we have measured our height in inch feet. That is also a British unit system. If I am talking about the relation, I will not prove the relation, because you know, if I am talking CGS and FPS relation, that is C by 5 equals to F minus 32 by 9. It's a very common thing. You all know that. If I am talking about the relation of in Kelvin, to Kelvin, T Kelvin is equals to 273 plus T degree centigrade. So if for temperature we have measured in degree centigrade, if you add 273 with it, we will find the value of Kelvin. Okay, so these are the units of heat and units of temperature that you know. Okay, Next part, which is the basic part of this chapter, there we have to enter now. Enter the Dragon. I think you have very much aware of the film. What is Enter the Dragon? Factors on which the heat energy of a body depends. Now we have to learn the factors on which factor the heat energy of a body depends. Let's see. The first factor, if I am talking about the heat energy absorbed or reduced by the body, depends on the mass of the body. It's a very interesting thing. If the heat energy is absorbed by the body is Q, it is directly proportional to the mass. More the mass, more the heat energy. I have given one example. Just now we have learned for 1 gram of water, if it is increased by 1 degree centigrade, the heat energy needed it is 1 calorie. But instead of 1 gram, if I have taken 2 gram of water, if you increase the temperature of 1 degree centigrade, then you need heat energy of 2 calorie. So more the mass, more the heat energy you absorbed. Okay. Similarly, in the opposite sense, if you see more the mass, you reduce also more heat energy. More you are having mass, more heat energy is reduced. So first one is mass. Number 2, temperature difference. When we have taken heat energy to a body, if the another body, if I have taken 2 bodies here, okay, if I have taken 2 bodies, I have just make 2 bodies in contact, when the heat energy will be transferred? Simply, if the temperature is different, if this temperature is high and here temperature is low, we all know the heat will travel from high temperature to low temperature. It is told that if the temperature difference between 2 bodies is more, then heat absorption will more. If the temperature difference is less, then heat absorption is less. So that's why that is shown by this way, that is the total heat energy is directly proportional to del T. Del T means, del T, it means temperature difference. Now you may ask, sir, why it is del? Why this del has come? Del stands for the difference. The diagram you have drawn now, assume this is a body, this is another body, assume its temperature is T1 degree centigrade, its temperature is T2 degree centigrade. If T1 is greater than T2, so the heat energy will be traveled like this way. The difference of the temperature, that is T1 minus T2, that is known as del T. Del stands for this del, this triangle, this del stands for the difference between 2 temperature. So here it is told, more the difference, more the heat energy absorbed. We feel that. Assume you have put one utensil just on the fire in your kitchen, and then you have touched the container, you will feel no heat energy is there because it is increased the temperature step by step. But if it is already been there in fire for a long time, if you touch the container, you will feel that sometime it may be a part of a great accident also. Okay, your skin is burned, okay, some problem will happen. So more the temperature difference, more heat energy will absorb by you. So these two are the factors. If I write it together, then we are talking about the heat energy. So Q is directly proportional to M del T. Q is directly proportional to M into del T. So one constant heat will come. Q is equals to Cm del T. This C, definitely it is a constant. What is the name of the constant? The name of the constant is specific heat capacity. We'll learn about specific heat capacity little later, but here I'm just want to make you a little clear. We have told the heat energy absorbed by a body depends on its mass and temperature difference. Now, specific heat capacity. This is a constant quantity for a body that I have told earlier. Now we have to see the physical significance of specific heat capacity. What is it? What is the need of it in this heat absorption? Assume you have taken two rods. Okay, two rods you have taken. Two rods is of same mass. One is iron, that is Fe, and another one is copper. Right? Two different rods of same mass you have taken. And after that, you have taken this rod to the roof. Assume at 8 o'clock, that time sunlight is there, and you keep it there up to 12 o'clock. So definitely it will absorb heat energy, and as they have just kept for same time interval, so we can say the temperature difference will be same. So we have seen the mass is same and temperature difference is also same. After that, these rods are taken, and if we just put thermometer, okay, so that is the answer. I have asked a question by which instrument we measure the heat energy, that is thermometer. First we touch the thermometer here, we will see a reading, and then the same thermometer will take and touch the another rod, we will see the reading is different. Why? The reason is that the heat absorbed by two rods are not same. Fe and Cu, this is not same. Why? That means there is some internal property of these rods are there on which the heat absorption it depends. This internal property depends on the molecular formation, the structure by which it is made, and that thing is related with the specific heat capacity. So specific heat capacity of any material, it is different. It depends on the structure of it. Okay, so you will learn more on specific heat but little later. So that is all about the things we have discussed, that is the factors on which heat energy is depends. So if C, M and del T of a substance is given to you, then you can easily find out how much heat is absorbed by a body. Now we'll go to the next part, that is the difference between heat and temperature. Okay, so we can do it earlier also, no problem with that, but here the factors, the idea of the factors we need to know. Okay, so the difference between heat and temperature, it is there I think in every book, so I will not write it down definitely. I am just telling one by one. So first one, definitely it will be the definition. Okay, what is the definition of heat energy? So heat energy is a form of energy which increases the internal energy of a body, or we can say in another word, heat energy is the measurement of, or heat is the measurement of internal energy of a body. Temperature is what? Temperature is particularly the effect of temperature shown in a body, or it is called degree of hotness or coldness on a body. If I am going by number 2, okay, so heat, absorption of heat energy depends on its mass and temperature difference. But for temperature, it depends on the heat energy. It doesn't depend on mass and temperature. It depends on, we can say, the internal energy, that means kinetic energy of molecules. More kinetic energy, more internal energy, more heat energy, and the temperature is also increased. Okay, so that's why it depends on the kinetic energy of the molecules. If I'm talking about the unit, it's the SI unit is joule and CGS unit is calorie. Here I am coming, here the SI unit is Kelvin and CGS unit is degree centigrade. Coming to the next one. Okay, if I am talking about the measurement, heat is measured by an instrument which is known as calorimeter, that we will know after some time, and it is measured by an instrument that is thermometer. Okay, thermometer. Okay. So now, if I am talking about the temperature, it doesn't depend on the internal structure of the body, the fifth one. But heat energy, we have seen, it depends on the internal structure, that is the specific heat of the body. So based on that, we can able to differentiate heat and temperature. Okay, so heat and temperature is not same for our body. Okay, that thing I just want to introduce here, but our main target is different, so that's why I'm not going in details. If you read this part, I think you can able to understand. Okay, I'll not go much on the difference of heat and temperature. What is our target? My target to the previous thing we have discussed, that is heat absorption by a body, Q equals to mc del T, where m is the mass, c is the specific heat capacity, and del T is the temperature difference. So from here we have to discuss about C, specific heat capacity. I have already told it depends on the internal property of a body, internal property of a substance, the formation of the body, the molecular structure of the body. The C can be measured by taking the ratio of Q by M del T. You see, C equals to Q by M del T. So from here, if I have taken that, if M equals to 1, del T equals to 1, then C equals to Q. So from here we can define the specific heat capacity. What is specific heat capacity? The specific heat capacity is basically the heat energy absorbed by a body of unit mass and when it is kept at unit temperature difference. The specific heat capacity is the heat energy absorbed by a body of unit mass m equals to 1 and the temperature difference of the body should be unit. Okay, that is known as specific heat capacity. If I find the unit from here, okay, so first I am talking about SI unit, Q by M del T. So unit of Q, that is joule, unit of M, that is kg, del T, temperature difference, that is Kelvin. So SI unit will be joule per kg Kelvin. That is the SI unit of specific heat capacity. And here another, if I am going for CGS, heat energy, it is calorie in CGS, gram for mass, and temperature, it is degree centigrade. So calorie per gram degree centigrade. So this is the unit of heat energy, a specific heat capacity of the units we have seen here. If I find the relation between them, the relation between joule per kg Kelvin into calorie per gram degree centigrade. Okay, let's see here. We know if I have taken 1 joule per kg Kelvin and here if I am taking 1 calorie per gram degree centigrade. 1 calorie means how much joule? 1 calorie means 4.2 joule. Okay, gram. So if I am converting gram to kg, it will be divided by 1000. Okay, 1 gram is there. So 1 gram means 1 by 1000. Okay, and if I am talking about degree centigrade, see, one thing we know, as we are talking about the difference of temperature, so it is same for Kelvin and it is same in degree centigrade also. It is same in Kelvin, it is same for degree centigrade. So this much joule per kg Kelvin. So when it will come, it is 4200 joule per kg Kelvin. Okay, so we can say 1 calorie per gram degree centigrade is equals to 4200 joule per kg Kelvin. 1 calorie per gram degree centigrade is equals to 4200 joule per kg Kelvin. Okay, so this is the equation of the units, and depending or using this one, we can able to find out one more important thing. What is it? That is heat capacity. We have learned specific heat capacity. Now we have to learn heat capacity. What is heat capacity? We will see. So it is clear, I think. Now we'll go for heat capacity. What is it? Heat capacity. What is heat capacity? It is told the heat absorbing ability of a body is known as heat capacity. How we represent it mathematically? Just now we have seen that Q equals to mc del T. All the things will come by this equation only. So here C equals to Q by m del T. If I multiply this m here again, so we say mc is equals to Q by del T. This mc quantity is denoted by capital C, and capital C equals to Q by del T, and this capital C is known as heat capacity. Heat capacity of a body. How? So here C equals to Q by del T, that is the heat capacity, capital C. If del T is equals to 1, then C equals to Q. So from here we can conclude that if the heat energy is needed to increase the temperature of a body of unit, then the total heat energy is known as heat capacity of a body. I am telling again, the heat capacity of a body is the amount of heat energy required to increase the temperature of a body by 1 degree centigrade or 1 Kelvin. 1 degree centigrade or 1 Kelvin, or to increase by unit degree centigrade or unit Kelvin, the total heat energy is known as heat capacity of the body, that is C equals to Q. Definitions are given in your book. Just read that and you can able to understand. Okay, so I am shown here that from where the equation has come. Okay, so if you understand this equation, you can able to make the definition. It is not like that you need to have the book all the time to read the definition. You have to do it, but if you understand the equation, you see C equals to Q by del T. If del T equals to 1, then C equals to Q. So C, it is the amount of heat energy is needed to increase the temperature of a body by unit. Unit means 1 degree centigrade or 1 Kelvin. Okay, and that time how much heat energy is absorbed, that is called the heat capacity. Talking about the unit of heat capacity, SI, so it is Q by del T. So SI unit will be joule per Kelvin. CGS unit will be calorie per degree centigrade, and 1 calorie per degree centigrade, that is equals to 4.2 joule per Kelvin. Because degree centigrade and Kelvin, what we have shown the logic in the previous explanation also, this degree centigrade and Kelvin is coming due to del T, that is the temperature difference, and temperature difference, it is same for degree centigrade and for Kelvin. If I am talking about the temperature difference is 50 degree to 55, so the temperature difference is 5 degree centigrade. Similarly, if I taking the Kelvin ones, we have to add 273. So if I add 273, it will be 323 Kelvin to 328. If you make the difference, it will be 5 Kelvin. So the temperature difference is same. So here degree centigrade and Kelvin, that will not change. So 1 calorie per degree centigrade is equals to 4.2 joule per Kelvin. Okay, this is the unit of heat capacity. Discuss the difference between heat capacity and specific heat capacity. What is heat capacity? We have already learned it. So first we have to write the definition. Heat capacity is amount of heat energy. Wow, what is the condition of the ink? Amount of heat energy is needed to increase temperature of a body by 1 degree centigrade. Heat capacity is amount of heat energy is needed to increase the temperature of a body by 1 degree centigrade. If I am talking to the definition of specific heat, that also we have discussed. This is amount of heat energy is needed to increase the temperature of a body of unit mass by 1 degree centigrade. So here no mass is there, only we have to increase the temperature of any body by 1 degree centigrade, and here we have to increase the temperature of a body of unit mass by 1 degree centigrade. Next one, it depends, by C it only we can say it depends on mass and characteristic of the body. If I am talking about specific heat capacity, it only depends on characteristics. Why? Because we have seen, you see, whenever we have find the equation, we have seen capital C equals to m into small c. Capital C equals to m into small c. So more the mass, more the heat capacity. It depends on the mass. And here you see this specific heat capacity is equals to Q by m del T. Here the mass we have divided. So it doesn't depend on mass here. Here if I give more masses, it will multiply with the specific heat capacity and more the heat capacity. So we can say it is not constant. That will write in the next part. It is not constant for a body. And here if I am coming, it is constant. It is constant for a body. It doesn't change. It doesn't change. But heat capacity, it can be changed. For different mass, it can be changed. Number 4. Heat capacity C equals to small m into C. What we have written, that is Q by del T. That is the equation. And if I am coming to here, specific heat capacity small c equals to Q by m del T. That we have seen. That is the difference. If I am talking about the unit here, its unit is this SI unit Joule per Kelvin. CGS unit calorie per degree centigrade. If I am coming here, its SI unit will be joule per kg Kelvin, and CGS unit is calorie per gram degree centigrade. So these are the difference between heat capacity and specific heat capacity. I think it is clear enough for today. Thank you very much.